Good day, everyone. This is the part two or the continuation of the chapter three, the lecture or the video lecture that I've uploaded, which is about measurement. Now, just a review of the part one. We describe measurement as a collection of quantitative data, also known as numerical data, which comes from the Greek word metron, which means limited proportion. And take note, measurement is needed because it is one of the measuring rather is one of the skills employed in science. So in science, in investigating the world around us, we need to gather data. So the data must not only be in qualitative data, it should be measurable. So dira na mo sulod, dira na to ma-inject ang quantitative data or numerical data, data that is expressed in numbers. Now, take note, measurement has two components. So when you measure, kinahanglan imuhang output naa siya'y magnitude or number and also a unit. So we give example of that like 5 kilogram. 5 is the magnitude or the number and kilogram is what we called as the unit. Now, in measurement also, there are three systems of measurement. So first, we have the English system. This English system, as I've said, is used mostly by the English-speaking countries. Sample of units are inches, foot, yard, and etc. Now, the second one is we have the metric system. This metric system is mostly used worldwide. Examples of units are meter, or the basic unit is meter. Now, this metric system was revised and it became now as what they called as International System of Units or the SI units. And again, in our part one of this chapter three or this lecture, I've or we've discussed about those basic units of SI such as mass and weight, length, volume, time, and then we have temperature. And sa temperature, I've given you problems or practice exercises wherein you have to convert one temperature scale to another scale. Take note that temperature has three scales. We have degrees Celsius, degrees Fahrenheit, and we have Kelvin. So you've already tried to convert one scale to another using the equations or the formulas given. Now, let's proceed with the part 2 again. So, since we are talking about SI units use prefixes to indicate the size of the unit relative to the standard unit. So, we do have the standard unit, for example, the meter. Now, there are measurement wherein it is greater than a meter or less than a meter na measurement. So by that, in SI units, there are what we called as prefixes. Now, the prefixes is attached, again, from the word pre, before, so attached to a unit. So, prefixes usually is in Latin words. So, here are the list of the prefixes with the symbol, and then we have the meaning, kung unsa iyahang equivalent. So, this is in grams, for example. So we have the tera, we have giga, mega, kilo, deci, centi, milli, micro, nano, and pico. So siguro you have heard measurement like centimeter. So meter is the basic unit, alright? So since if we add a centimeter, it is less than a meter. So that is why pag mingon tag centimeter, gamay pa na siya og measurement sa meter. But if we talk about kilometer, higher or greater than iyahang or the size niya is greater than that of the standard unit. Now, In this prefixes or SI units, we can convert one unit to another unit. Example, so we have 5 kilogram. We have what is the equivalent of 5 kilogram into milligram. So take note again, the kilo and the word milligram is Latin prefixes or prefixes. Now, in converting this one, we have to use conversion factors. So since the involved nga unit kay kilogram o milligram, so pangitaon nato pilang equivalent sa kilogram o milligram into the table. Again, kani siya. So unsa ganito siya, we have the kilogram and then we have the milligram. So ang kilogram, so we have 1,000, or it can be written as 10 to the power of 3. For the milli, we have 10 to the power of the negative 3. Okay, let's go back to the example. Now, again, so 1 kilogram, 10 to the power of 3 grams. So, that kani siya, gikuha na ko dito sa table again. Tapos, we have 1 milligram, we have 10 to the power of negative 3 gram. Now, let's do the solution. So we have here milligram because this is the unknown kung or ang ato ang pangitaon. So we have milligram is equals to, we have the given 5 kilogram. So we will use the conversion factors. So we have open parenthesis and then 10 to the power of 3 gram over 1 kilogram. So kilogram kani siya is kani diri na to gikuha. Okay. Next, we have another conversion factor, 1 milligram kani, and then we have over 10 to the power of negative 3 gram. So take note again, these are what we call conversion factors. We get this one from the equivalent or sa table gaina. Now, let's proceed. So again, copy 5 kilogram. So 10 to the power of 3 gram, multiply it with 1 milligram. So naanatay 10 to the power of 3 milligram. Next, 1 kilogram multiply by 10 to the power of negative 3 grams. So we have 10 to the power of negative 3 kilogram. Next, 5. Before we'll proceed with this one, take note that the units, this one, the unit of 5 is kilogram, right? And then the unit of this is kilogram. Above, the numerator is milligram. So since they have the same unit, so we have to cancel this kilogram and the kilogram here. So mawala na ng kilogram dira sa 5, mawala po dari ang kilogram sa 10 to the power of negative 3. So what will happen next? 5. So wala na siya unit. So 10, we just have to copy. Okay, the same raman na sila. So ang buhaton nato is we have to solve for the or calculate for the exponents, or rather exponents. So unsa gani exponent diri sa numerator? So we have positive 3. So 3 na siya. And then for the denominator, negative 3. But take note, in doing or in calculating the doing the math in involving exponents, take note pag division i-minus nato, subtraction. 'Di ba kung sa multiplication i-add sila. Pero since divide man ni siya, division man ni siya, so ang buhaton nato with the exponents, we have to subtract. So 3 man na siya, so assume nato minus, and then negative 3 man na siya. So take note that positive minus negative, so duhaman nga negative ang nagtapad, so ang mahitaboan na it will become positive. So maong na positive na siya, nawala ang negative. So we have 3 plus 3. Then we have the unit milligram kay nawala man ang kilogram. So after that, bring down again the 5. Now this 10 will become 10 to the power of 6 because we added 3 the exponent from the numerator with the exponent from the denominator. Again, it became positive 3 because we subtract 3 to negative 3, and then it will become 3 plus 3. And so that will be 10 to the power of 6 again, then copy the units, milligram. Next, you have to copy. So we now have this equivalent of 5 kilogram. So we have 5 times, because of the parenthesis, 10 to the power of 6 milligram. So that is now our answer. Take note again, we have to use conversion factors. So ang gamito ninyo nga conversion factors are the unit nga involves ato ang problem. So again, since kanya tong ginagamit, because take note, kilogram o milligram ang involved. Kani siya ang equivalent. Where do we get this one? We get this one from the table. So again, we have a kilo, 10 to the power of 3. We have milli, we have 10 to the power of negative 3. So, mo na siya. So, himo na tong conversion factor. So, then cancel. And then again, subtract the exponents. And then you can have now this. And it could be written as 5 times 10 to the power of 6 milligram. Now, let's proceed. In units or SI units or quantities, we can derive or we can have another units from the relationship or combination of the basic units. So again, from the word derive, so meaning nigikan siya sa mga standard unit or basic unit. Gi-combine nato ang mga units. So some examples are, we have speed. So pag mingon tag speed, it is a derived quantity that shows the relationship between length and time. It is the ratio of a distance covered by a body to the time taken. So, what are the two quantities or units nga atoang gi-combine? So, take note again from the definition of the speed, length og time. So, take note si length is a standard unit or quantity, tapos time is another standard unit or quantity. So we combine or we get the relationship between sa length, the distance between point to point, and then we have the time. So, ang mahitabuan na, it will become now what we called as speed. So, ang speed dayon nga ni resulta, that is i-derive quantities. Now, another one is velocity. If our speed kay naa siya'y direction, and then iyahang unit will be meter per second, that is what we called as velocity. So therefore, si velocity also is a derived quantities or units because it talks about the relationship between length, time, and then direction. So the formula for the speed is we have this symbol, small v or speed is equals to x, that is for the length, or sometimes it is d, small letter d over t. T is for time, and then this is for the same with velocity, but usually there is a bar above this symbol na v. So another derived quantities is we have density. Now, when we talk about density, it shows the relationship of mass to the volume of an object. It is the ratio of mass and volume under a specified temperature and pressure, which has a unit of meter per second. Now, take note again, density is a derived units because it is a combination or nagpakita siya og relationship of duha ka standard unit. So what are those standard units that shown or ginapakita ni density? So take note, relationship of mass and volume. Maong kitawag siya og derived quantities or units. So take note again, speed, velocity, density, ug uban pa nga examples are what we call derived quantities or units when these quantities are showing the relationship between two standard units. So for example, for speed again, balik ko na ako, we have length og time. For velocity, we have length, time, and then direction. For density, we have mass and volume. That is why they are called as derived quantities. Next, aside from this derive quantities in units, conversion of units, in measurement also, it is very important to know the accuracy and the precision of the measurements, or how exact a measurement is. Because take note, in measurement, we use different tools or instruments to measure certain object, or any examples that we have, or we compare. If we were going to compare one object to another, so the degree of error of, for example, those instruments are never exact, so naagi yung mga pwede nga magkamali or differences. So the degree of error depends on the measuring instrument again, and the person making the instrument. Now, there are two ways of checking these errors. So, dira na mosulod ang gitawag nato og precision and accuracy. So, when we do measurement again, naagyo yung mga tendency that the measuring device kay pwede nga dili exact iyahang mahatag, or pwede pod factor is the one doing the uh, measuring, or the person making the measurement. So maggamit ta og principle of precision and accuracy. Let's start with precision. So precision, it tells how close several measurements are to the same value. When this happens, the measurement is said to be precise but not necessarily accurate. So kaning precision, it shows or tells us how close, or how close it is to the several measurements on the same to the same value. But take note, not necessarily mean nga precise siya ang measurement, accurate na siya. Okay, example na to. We have three students measure the mass of a piece of copper that weighs 3.00 gram. Now, these are the trials. So, na siya four trials. We have student A, three students man ang nag-measure, student B, and we have student C. So, can you see the differences? So, trial 1, so kani ang nakuha sa student A. Kani pod ang sa student B, and this is for the student C. Now, if there is a significant difference among the measurements, the precision is low or poor. So if again there is a significant difference, na ay differences sa mga measurements, the precision is low or poor. But if the measurements differ in small amounts, gamay rang ilahang bikil or kalahian, the precision is high or good. Thus, student B has the most precise measurements. So again, if ato ang lantawon, sa student A, trial 1 niya, 2, 3, and 4. So, 2.970. So, ikaduha niya, 2.971. So, if we look for the measurements nga nakuha sa student A, iyahang precision is low, right? Because naagi significant differences. 70, 970, then mahimong 971, 967. But the same with the student C. If lantaw na to na ay significant differences, which is ang precision niya is low, likewise sa A. But if you're going to look at the measurement sa student B, there is the measurements differ in small amounts. So, for example, in trial A, trial 1 ni student B, 3.00 gram iyang nakuha. Pag abot sa iyang trial 2, naalay gamay nga difference. Okay, so 1 then 2, but it is close to the several measurements nga iyang nakuha. So thus, student B again has the most precise measurements. So that is what we called precision. Take note again, not necessarily accurate if high or good iyahang precision. So take note again, precision is how it tells us how close several measurements. Kani several measurements man niya kay kapila man sila nag-measure o kaupat. So if lang tawo na to iyahang mga nakuha, very close gyud iyahang mga measurements unlike sa duha. Now, since we've talked about precision, what about accuracy? Now, accuracy tells how close a measurement to the true or accepted value. A measurement that is accurate or has a high accuracy is one that is close to the true value. So example, in the table, student B also has the most accurate measurements being closest to the true value of 3.00 gram. So man to ang equivalent na illustration nato. So take note ang accuracy is kanang accurate or kuan na gid siya kanang close to the measurement of true or accepted value. So take note ang measurement nato gaina is ang copper nag-weigh siya into 3.00 gram. Mo nang to ang accepted value nato, 'di ba? So since si B man ang ato ang naay high or good precision. So in terms of accuracy, siya pod ang student B pod has the most accurate measurements because take note naaman siya sa trial 1 pa lang niya nakakuha na siya og 3.00 gram which is our true or accepted value. So that is precision and accuracy. So take note when you do measurements, you have to observe this precision and accuracy. So you have to consider this two. Now, aside from precision and accuracy, in doing measurements also, we observe that there is always some degree of uncertainty due to experimental error. Again, pag mag-measure dili man gyud again exactly nga makuha. So nagyo ni mga differences. So for example, the mass determined using a simple balance is 4.8 gram. When a more sensitive balance is used, so we use another instrument or tools, the same object weighs 4.82 gram. So can you see the difference? At first nato nga pag-determine sa mass using a simple balance kay 4.8 gram. Then pag we use another um, balance or instrument, it became 4.82 grams. So na ay different. So there is a degree of uncertainty again in the final or last digit. So the 8 in 4.8 gram and the 2 in the 4.82 gram, then preceding digits are certain or definite. So unsaon nato pag identify aha may significant ato nga figures or digit from the different measurement or uncertainty. So we now have what we called as significant figures. Now, significant figures include all the digits, whether certain or uncertain. Now, there are rules that we have to follow in determining the number of significant figures obtained from a measurement. First rule, all non-zero digits are significant. Take note, tanan nga number nga dili zero, except si zero, so 1, 2, 3, 4, 5, 6, and so on, are all significant, consider significant. Take note, si zero is not significant. But second, all captured zeros or zeros in between non-zero digits are significant. Pag ang zero, since diri man gud sa first rule na to, s- uh, we've stated or we've described zero as not significant because all non-zero man ang significant. So pag abot sa ikaduha, pag si zeros ka in between gitungaan sa duha ka non-zero, consider siya at significant. Example na to, 202. So 202, pila man na ka digit? So naatay tulo. 2, 0 ug 2. So take note, all non-zero digits are significant. So si 2 og first nga 2 og ika-last nga 2 are consider sila significant. But si 0 kay naaman siya sa center or in between gitungaan sa duha ka 2. So nakabutang diri that all captured zeros are significant. So kato siya is considered as significant. Next, trailing zeros or zeros before or after the decimal point are significant. So again, trailing zeros or katong nga zeros before or after the decimal point are significant. So we will give example later. 4. Starting zeros or zeros at the beginning of a number are not significant. Take note again, starting zeros, mga zeros nga gauna, beginning of a number are not significant. Lastly, ending zeros, zeros at the end of the number are not significant. Take note, wala ni labot og decimal point. So let's give examples. Have examples here. So 25 milliliter. So 25, non-zero man na sila. So take note, pag non-zero is significant. So pila man na to ang significant figure? 2. So we have 2 is a significant figure, 5 is a significant figure, so 1, 2, maong 2 ang iyahang significant figure. Second example, 5,002 millimeter. So there is no decimal point here, and then two zeros are what we call captured zeros or zeros in between non-zero. Kay kaning duha ka zero, gitungaan sila sa 5 ug 2. So si 5 ug 2, consider na sila at significant, right? So therefore, these two zeros are considered as significant. So we have four significant figures. So 1, 2, 3, and then 4. Next example nato we have 0.050 kilogram. Now take note again in our rule, kaning 5 and then zeros, diba in ending zeros are considered significant. So balik ta sa ato ang rule. So take note, starting zeros at the beginning of a number are not significant. Then we have trailing zeros are significant. So we have, again, balikta. So we have 0.050. So two significant figure because we have here 1 and 2. Kani silang mga zeros kani are not significant na sila. Kaning duha nga zeros. So other examples kay naa sa inyohang manual. Okay, so you can refer to your manual for other examples. Now, if the measurement has lots of or daghan siya og digits and needs to keep either kwaon lang nato siya into kung unsa lang ang significant or to make the measurement has a lesser number of digit, so we are going to apply rounding off. So rounding off is needed. So here are the rules in rounding off. So again, these rules are already not new to you. So familiar na mo ani. So first one, numbers followed by 1 to 4 stays as is. Numbers followed by 5 is conditional. If even, as is, dili na to ilisan. If odd number, example 3, 5, 7, we will add 1. If numbers followed by 6 to 9, you have to add 1. Examples, kani siya, 43.56. So we have this one. So we have 40. It will be, it can be round off as 44, because take note, 3, this 3 is odd number, so therefore we have to add 1. So instead of 43, we can write this one as 44 milligram. Next example, we have 5.983257843 centimeter. So 5 is an odd number. So therefore, what is our rule? We have to add again 1. So, ang mahitaboan na, so it will become 6 centimeter. If baliktaron nato that kaning 3, himo na to na og 2. So, 42.5. So, since 2 is even, ang mahitabo is 42.5 or 42 ra siya. Okay, nakuha? So, that is for the rounding off. So, next nato, aside from significant figures, determining significant figures, we also have what we called as scientific notation. Scientific notation is a number which is naa siya'y duha ka parts. So we have the first part is number between 1.0 to 9.9. The second part is a power of 10. Or kaning shown below. So we have this number times to the, then we have 10 to or the power of 10. So the exponent kaning y can be positive or negative. So ato nang i-discuss later. Nganong ma-positive siya or nganong ma-negative. So what is the use of the scientific notation? Take note that many numbers in measurement kay either large or very small ang number of zeros nga difficult siya i-handle. So para ma-accurate, for accuracy again, we're going to use scientific notation. 'Di ba na yung mga numbers that, for example, 2.92000 and so on. Taas kayo siya og zeros. So it will be difficult for us. So para ma-accurate siya, so we're going to use the rule of scientific notation. So again, scientific notation has two parts. Naa siya'y kaning number ug naapod siya'y power of 10. Now, what are the rules? First, to write numbers in scientific notation, move the decimal point such that you have a number between 1.0 to 9.9. So, mag-move ta og decimal point. Next, determine the correct exponent by counting the number of times the decimal point is moved. So kung kapila ta nag-move og decimal point, mao po to ang exponent nato. So you have to determine how many or step or kapila ta nag-move og decimal point. Third one, when the decimal point is moved to the right, so take note to the right, the exponent is written as a negative number. So exponent nato iyahang sign niya is negative when we move it to the right. But if we move the decimal point to the left, the sign would be a positive or the number would be positive. So let's have example. So we have here 0.00567. So that is our measurement nga nakuha. So take note na yung mga zero, daghan kayo siya og kuan. We have here 1, 2, 3, 4, 5, 6, 7. 7 digits. So to get the accuracy sa measurement kani siya, so we will apply the rule of scientific notation. So what is the first rule that we have mentioned? Balik ta again, we have write numbers in scientific notation, move the decimal point such that you have a number between this one. So take note again, determine or we will count pila ta naka-move og decimal point. And take note, pag right ang atohang direction, it is in negative number. If the direction nga nag-move ta is to the left, the number will be positive. So we have here, so naadari ang decimal point, right? So we will move, haman ta mag-move. So we will move to the right. So we have here, so this decimal point, you move it there, 1, then move to another 0, 2, and then we have 3. Take note, dito ta mag-stop sa pinaka first nga significant figure. So ang first significant figure manggod nato is 5, tama? Kay 5, 6, ug 7 significant figures man na sila. Non-zeros man sila, tama? So ang decimal point nato mag-end or mag-stop there is a first significant figure. Baliko na ko again. This is the decimal point. So we're going to move to the right. So 1, 2, and then we have 3. So we can write it as this number 5.67. Point na siya or decimal point because take note, gimove na to ni siya padulong diha taman sa first significant figure. So we have times. Then we have 10, power of 10. Take note, ang part sa scientific notation, number og kani siya. So kaning times og kaning 10, given na siya. Ang mag-matter is kung kapila ka nag-move. So mo na isulat diri sa exponent. So how many times we moved the decimal point again? We have 1, 2, 3, katulo. So ang direction magud nato is towards the right. So mahitabo the sign niya is negative. So negative 3. So 5.67 times 10 to the power of negative 3. Another example here, 456 thousands. So we have 4, 5, 6, and then kaning tulo ka zeros are the digits na given nga measurement. Now, take note again, mag-end ta or ibutang nato ang decimal point at the first nga significant figure. So, since these are all significant figures naman ni sila tanan, so darita magsugod towards the left, padulong sa left. So, we assumed wala man ay decimal point, so naa diri ang decimal point. So, move ta, take note again, count pila kapila nag-move. So we have 1, 2, and then 3, 4, and then we have 5. So take note, dili ta pwede mulapas sa 4 because 4 is already the first significant figure. So we'll put decimal point here so we can write it as 4.56. So dili na apilon ang mga zeros times, then 10. So how many times did we move the decimal point again? We have 1, 2, 3, 4, 5. So 5 ang ato ang exponent. Positive siya because atong direction is padulong sa left. So again, this one, ang gibuhat nato is we move the decimal point to the right. Then, nag-end ta sa first significant figure, which is 5. So, mo nang nahimong 5.67. Wala na siya. Then, again, times 10. Negative 3 na siya because we move the decimal point katulo. And towards the right man siya, so negative. Kani siya baliktad. We move the decimal point to the left. So, we have 1, 2, 3, 4, and then 5. So, maong 5 ang exponent. Now, the opposite of scientific notation is what is known as expanded notation or standard notation. Kani, this is standard notation. Kani siya, again, is what we call scientific notation. So, pwede po ta maka-convert or atong balihon. We have to write scientific notation into standard or expanded. Kani manggod siya is from expanded notation, we write it into scientific notation. Now, examples here from Scientific notation, we will write it into expanded notation or standard. So again, we have 5.67 times 10 to the power of negative 3. So take note again, the exponent is mo na siya ang number of move nato decimal places. So you have to copy this one and then sulat nato diha. Then we will move the decimal point. So we have to the left, so we have 1. So kung naa siya diha, so we have 1, 2, and then 3. So we will add 0. So we can now have the expanded notation. The same with the second example again, 4.6. So isulat nimo ang 4.6. I-move nimo ang decimal point kalima because 5 man ato ang exponent. So we'll move kung naa direng decimal point. So 1, 2, 3, 4, and then 5. So you now add zeros. So that is how to write scientific notation gikan sa expanded or gikan sa scientific notation himuon nato og expanded notation. So again, take note, significant figures or significant digits kay ato ang i-determine kung asa man ang mga digits that considered siya as significant. And then, scientific notation is kung unsa ang accurate nga measurements depending on the size of the measurements nga to ang nakuha. So take note again, you have to follow the rules in, for example, balik ta sa significant figures, you have to follow these rules in determining the significant digits. Likewise, in writing scientific notation, you have to follow these rules. So I think that's conclude our discussion or the part 2 of the chapter 3, which is about measurement. Again, if you have questions or clarifications, you can PM me or ask me your questions or clarifications. So thank you and then God bless.